Okay, so what we're going to do is we're just going to have a little bit of a review of y equals mx plus c. So hopefully if I can just bring up a pen here. So here we go. So first thing I'm going to do, I'm going to draw a line. Y equals 5. Y equals 5. Dead easy line. Dead easy line, okay? Some of us might be saying, hey, what about y equals 2x plus 4? No, let's just start off with y equals 5. Hey, check it out. You seen the line I've just drawn? That's y equals 5. And I know it's y equals 5 because every point on this line is 1, 5, 2, 5, 3, 5, 4, 5, 5, 5, 6, 5, and so forth. Every line, every point on that line there, the y value, the second value is 5. Okay, so what about x equals 5? Let's draw a line of x equals 5. There we go. There, x equals 5. Too easy. So this here, this is y equals 5. And this line here is x equals 5. Some of these would look really good in your, like a cheat sheet. Yeah, in a cheat sheet, something like that would look really good. Okay, next thing we're going to do, let's just draw some basic lines. Let's just draw this. Y equals 3x minus 1. Alright, so what we do, we start off at -1. We start off at -1 on the y-axis, because it's got -1 there. And every time we go across 1, we go up 3. Every time we go across 1, we go up 3. Can you see what I've just done there? Every time we go across 1, we go up 3. I'm just going to mark that up. Every time we go across 1, we go up 3. Easy. Alright, what if I asked you to do this? Y equals 1/2 x plus 4. Y equals 1/2 x plus 4. So all we do, we start off at plus 4, and every time we go across 1, we go up a half. Can you see what I've just done there? Every time we go across 1, we go up a half. Okay, what if we do something like this? Y equals 2/5 x minus 6. Oh, nightmare. No, it's not a nightmare. What we do, we start off at -6. We start off at -6, and every time we go across 5, we go up 2. Can you see what I've just done there? Can you see I've gone across 5 and I've gone up 2. I go across another 5 and I go up another 2. There we go. Can you see what I've just done there? So we go. So what we're saying here is every time for this one, every time we go across 5, we go up 2. Simple as that. All right. Okay, one more. Just delete some of these. Okay, so what if we do something else? What if we do this? Y equals -3x plus 5. So where do we start on the y-axis? We start at +5, and every time we go across 1, we go down 3. Every time we go across 1, we go down 3. Simple as that. How easy is that? Too easy. Okay, now, what about if we get it in a different format? What about if we get something like this? X plus y equals 4. So, remember we've done these before. If x is 0, y is 4. If y is 0, sorry, done that wrong. Yeah. If Yeah, so if y is 0, x equals 4. If x is 0, y equals 4. And all we do, we join those up. So we join these two lines up, these two coordinates up. Join them up. Simple as that. Okay, let's do another one. X minus y equals 3. X minus y equals 3. So, if y equals 0, x equals 3. Okay, and if x equals 0, y would have to be negative 3. Y would have to be negative 3, because remember, negative, whatever y is, negative 3, well, we know that two negatives give us positive 3. So now what I do, I'm going to join these 2 points up. Now, if this was a simultaneous equation where the two of them intersect, where the 2 points intersect, that would be the solution of our simultaneous equation, but we're not doing that. Okay, so next thing, what about if I'll just give you one more of these? Okay, what if we did this? Okay, so put it in the wrong order, but anyway, so if y is 0, that means x would have to be negative 4. 3 times what is negative 12? X is negative 4. Okay, if x equals 0, negative 2 times what is negative 12? Y would have to be 6. Okay, and then all I'm going to do is just join those two coordinates up. Okay, right. Next thing. Right. Just going to do a bit of writing. We'll just ignore this. So I'm going to write this down here. Y equals 4x plus 20. So what does that 20 give us? It gives us the y-intercept. What does the 4 give us? Well, that's the gradient. Okay. Now, what we have to be really careful of is that if I write this down here, 2y equals 12x plus 40. Hey, does this now have a gradient of 12? No, it doesn't. Does this have a y-intercept of 0, 40? No, it doesn't. What we have to do, we've got to divide everything by 2. So y equals 6x plus 20. That's much better. Alright, okay, so now it's got a gradient of 6 and a y-intercept of 0, 20. Perfect. Alright. What about if you want to work out the x-intercept? How on earth do we actually ever find out this x-intercept? Okay, so I'm just going to write this down. Pens. So I'm going to write down x-intercept. How on earth do we find the x-intercept of y equals 7x minus 21? So all we do to find the x-intercept, we have to make the y value equal to 0. Okay, because remember, the x-axis is also known as y equals 0. Right, okay. So it's like, here's my little fence. And what I need to do is I need to get my x's on one side and my constants on the other. So watch what I'm going to do. I'm going to add 21 to that side. I'm going to add 21 to this side. 21 equals 7x. So if I want to work out what x is, I divide this side by 7. I divide this side by 7. Perfect. So where is my x-intercept? 3, 0, because these two 7s kill each other off. So 21 divided by 7 is 3. Perfect. So that's all I have to do to work out the x-intercept. All I have to do is make the y value equal to 0 and solve the equation. That's all I do. Right, what else do we do? Okay, so say for example, I've got 2 coordinates. Here's one coordinate. Here's another coordinate. Alright, so what we do, how do we find the equation of a line between these 2 coordinates? So what we do, we call this one x1, this one y1, this one x2, this one y2. So now we write down m, the gradient, equals y2 minus y1 over x2 minus x1. So we've got 27 minus 7 over 6 minus 4. All right, okay, so that means we've got 20 divided by 2, which is equal to 10. Perfect. All right, so now we write down y equals mx plus c. And this is where you get to choose a coordinate. Now I think I'm going to choose this coordinate here, 6, 27. So I'm going to write down 27 equals, what's the gradient? The gradient is 10 times, what's the x-intercept? What's the x value? 6. Hang on a second. What, 10 6 is a 60. What do I have to do to 60? Go down to 27. I need to take away 33. Right, so now I know the equation of the line that links these two together. Y equals 10x minus 33. There we go. I found out the equation of the line that connects these 2 points together. Easy. All right. So we're definitely going to be doing that. What else could we be asked to do? What else could we be asked? So I'm going to pick one of these coordinates here. Okay, so I've just got coordinate 4, 7, and on this coordinate 4, 7, I've got the line with a gradient of, pick a number, 6. Alright, so I'd love to know, what is the equation of a line that intersects this coordinate at 4, 7? So there's 4, 7. Can you see that's 4, 7 right there? And what's the equation of a line that intersects 4, 7 with a gradient of 6? So what we're going to do, let's write down y equals mx plus c. So what's the y value? 7. What's the gradient? 6. What's the x value? 4. Hang on a second. 7's not 6 times 4. 6 4's are 24. So how far is it from 7 up to... so what do I need to do to 24 to move all the way down to 7? I need to subtract 17. Yeah, there we go. So I need to subtract 17. Perfect. So now what I'm going to do, so Daisy, I'm going to write down here, y equals 6x minus 17. So that is the equation of a line that intersects the coordinate 4, 7 with a gradient of 6. All right. Now, What else might we be asked to do with linear graphing? So here we go. Here's a taxi. Okay, so how much does this taxi cost per kilometre? How much does this taxi cost per kilometre? I think it costs 75 cents. How much is the standing charge? The standing charge is, well, it's $20. $20, so the minute I get in the taxi, I have to pay $20 before the taxi even moves. So how much does a 10-kilometre journey cost? A 10-kilometre journey is just going to be 10 times 0.75 plus 20. So that means it's just going to cost me $27.50. So 10-kilometre journey would cost me $27.50. Okay, how far can I travel with $50? How far can I travel with $50? So I just do everything in reverse. So I do 50, then I minus 20, and then what's the opposite of multiplying by 0.75? I then make sure I press equals, then I press divide by 0.75, and that will tell me how far I can travel for $50. Easy. Oh my word, easy. Too easy. Okay. Right. Some of the more advanced things we might be asked to do is finding the midpoint. So, I should use it, won't I? So, here's two coordinates. There's one coordinate, which is -5, -2. And here's another coordinate, which is 3, 7. Okay, so I want to find out what is the coordinate of the midpoint between these two. So, to find the midpoint, oopsie-daisy, to find the midpoint, first way is we add these two numbers together, -5 plus 3. So we add the two numbers together and we divide by 2. So -5 plus 3 divided by 2. So -5 plus 3 is -2, divided by 2 is -1. Okay, and then we add these two numbers together, -2 plus 7, and divide by 2. -2 plus 7 divided by 2 is going to be 2.5. So if I find -1, 2.5, you see that point there? So -2, that's right. Oopsie-daisy. Just undo that. Yeah, so there we go. So that coordinate there is going to be -1, 2.5. Now, what's the formula for getting the midpoint? Okay, the formula for getting the midpoint is, so we do x1 plus x2 divided by 2. That will give you the x value, and the other coordinate is going to be y1 plus y2 divided by 2. Okay, that is the formula for working out the midpoint. That would look really good on a cheat sheet, that formula. That is how you work out the coordinate of a midpoint. The other thing that we might be asked to do. Okay, I'll just delete some of this lot here. Okay. Right, in fact, I'm going to just use... Oh, here we go, yeah. Right, next thing. How do you find the length of a line? So, here's a coordinate. So, -5, 1. Sorry, I'll write this down properly. 1, -5. Right, where's the other coordinate? The other coordinate is going to be here. 6, 6, 8. Alright, so I need to find out the length of this line. What's the length of this? What's the length of this line? Okay, so now what I'm going to do is, you can see that from this point here, from 1, -5, to this point here, which is 6, 8. Okay, so can you see that I'm travelling along 5 places, aren't I? And I'm travelling up 13 places. So, whose theorem am I going to use to work out the length of this line? Whose theorem? Well, I'm going to use Pythagoras' theorem. So, I'm going to do 5 squared plus 13 squared, and that will tell me the length of that line. So I'll just work this out, and you can work it out, and give yourself a big pat on the back if you got 13.93. 13.93 units. That is the length of the line. Awesome. Okay, so now, right, how do you actually, what's the formula for this? What's the formula for the length of a line? The length of a line is this. Remember to use brackets. There you go. That is the formula for the length of a line. Again, that would look really good on a cheat sheet or in a summary book. Okay, right, so that's about it for linear graphing. I think using all this information, I actually think that you'd have enough information to actually ultimately get you through everything that we're going to ask of you. All right, good luck.